They're dense.
Are they expensive?
Expensive is all based on how easy it is to get the material. Okay, so let's take this formula apart. A longer wire, if I have two wires, the exact same wire, a longer wire and a shorter wire, which one has more resistance?
Longer wire.
A longer wire. Bigger L gives you bigger R. Cool?
Yeah.
Okay. Now, a thicker wire versus a thinner wire. Same length, same material. Which one has more resistance? A thick wire or a thin wire? A thin wire. Bigger A, smaller R. Okay? Thick wires have less resistance. Thin wires have less resistance.
Wait, what?
Yeah. Thick wires have less. Thin, sorry, did I say thin? I meant short. Short wires have less resistance.
Okay, you said thin and thin, they both have less.
Sorry, I didn't mean to confuse you. Don't cry. So, thick wires have less resistance and short wires have less resistance. Okay, what is Ohm's law really? Ohm's law basically says a material will have the same resistance regardless of the voltage applied to it. That's really Ohm's law. V equals IR is just something we just kind of co-opted. But Ohm's law is really a material will have the same resistance regardless of the voltage applied to it. Has no one been gone this whole time? Yeah. This is Jackson. So this is what this means. You have a wire. You apply 1 volt to it, it has the same resistance whether you apply 1 volt or 100 volts. Okay? So if I take a paper clip and I hit it with this, it'll have the same resistance whether I hit it with this or hit it with a lightning bolt. That's what Ohm's law says. In reality, what really works is if I have my paper clip and I run some voltage through it, so I'm going to have Brinley hold on to this, I'm going to zap it with the Tesla coil, and then she's going to tell me what it feels like whether I hit it with a lot of energy or a little bit of energy. Now she's saying no.
I'll do it.
So Ohm's law basically says it doesn't matter how much voltage you use, it'll have the same resistance. So what this practically means is this. We say this material is ohmic up until this voltage. Okay? So if I try to send a lightning bolt through my paper clip, this thing's just going to blow up. It's going to basically fall apart at the atomic level. A lightning bolt will not be able to go through this. A 9-volt battery, no problem. My Tesla coil, no problem. Okay? So what we would say, this material is ohmic up to, let's say, 1,000 volts. Yeah?
Instead of not the lightning bolt.
It could not take a lightning bolt. Because if we put so much voltage through this that the material will basically fall apart, it's no longer ohmic.
I thought you meant a lightning bolt to the 9-volt battery.
Oh, right, okay. So multiple choice question, ladies and gentlemen, before you're out of here. Multiple choice question is if you wanted to look at a graph of something that is ohmic, and we graphed the resistance versus the voltage, what's that graph going to look like? It's going to be a straight line until it goes to 0. Okay? So as we rank up the voltage, something that is ohmic has the same resistance regardless of how much voltage you give it until it's not, and then it falls off to 0. Should you find this on a multiple choice, you better get this right.
On this